Welcome back, everybody. I hope you had some good discussions, and a big thank you to the facilitators of the different breakout rooms for managing the talks and then also the subsequent discussion. So this session is about pulling it a little bit together. We would like to hear what happened in the different rooms, what the focus of the discussions were. Obviously, we only have 20 minutes for what was basically a 6-hour session in 4 different breakout rooms, 90 minutes each. So we have to be quite concise. I have a few questions for you four, and feel free to bounce these back and forth between you. I think the more dynamic we can have this, the better. And of course, the audience, as always, is also very welcome to engage with us. So if you have any questions, just pop them into the Q&A, and we can pick those up as well in this session. So to get us started, from your different perspectives in the different sessions, what do you feel stood out as the most promising or maybe most transformative application of AI in your session? Debdeep, would you like to start?
Oh, yeah, sure. I will quickly summarize through my session. So our breakout session A, which was the physical AI for product development. So we explored how artificial intelligence is transforming the development of complex physical products across diverse industries. It could be from radiation detection, spectroscopy, gamma ray spectroscopy, to complex industrial challenges like metal castings, as presented by Dr. Jim from Marine Technologies and by Dr. Douglas from Physics X, respectively. So Dr. Jim provided a very nice insights into the cutting edge use of artificial intelligence in gamma ray radiation detections while addressing the complex challenges of nuclide identification, peak detections, radiation source characterizations, etc. And also the ability, artificial intelligence ability to analyze intricate spectral data and potentially enhance the accuracy of and the efficiency of the radiation monitoring. The discussion also touched upon the critical need for robust and diverse data sets, which is not very much available because that's very much needed to train these AI models effectively. And on the other hand, Dr. Douglas demonstrated a compelling application of AI in revolutionizing the design of manufacturing of the metal casting industries. So their experience-led approach to building trust in AI via data-driven validation and the integration of physical contents offers a valuable blueprint for adapting artificial intelligence in high-stake related customers and engineering applications.
Maybe just to follow up on this. So is there, you mentioned performance improvement through AI. Is that mostly what came out of this, or were there also fundamentally new diagnostics, for example, enabled by AI? So was it a step into the direction of a better performance, or were there really any game-changing improvements?
So it was the case, like time-consuming wise, while the traditional simulation, the Monte Carlo one, while taking, and then from there to the stage of prototyping, were taking several days. That time could have been mitigated in hours to a couple of days. So that was a really, really big leap. One really nice question came up on that topic, thing from Shakti, whether this was primarily targeting for any specific material like iron, for example, or it could also be extended complex material like fibers, which is still under process, they said. So yeah, those things could be even.
Yeah. I mean, how was this in your session, Andrea?
So it was very interesting. I was still working on my notes. In safety and risk and highly risk environments, keywords that were mentioned were, of course, digital twins. This is because we usually cannot interact directly with these very risky environments. So our 2 talks, one was about air traffic control, which has very complex behaviors, and also it's currently purely human decision making. But by 2050, the industry is expecting that these decisions are fully automatized. So they're currently laying down the roadmap. And we also heard about safety in fusion control, So in both cases, digital twins are extremely important so that we can predict in a safe way and also train models. Also, highly explainable decisions was one of the keywords that were mentioned. Because if we have a human that we want to augment with AI, let's say at the beginning, if they're going to take a decision, they need to understand why. Otherwise, we might be putting some lives at
Right.
risk or some systems at risk. So
You
explainability.
know, just on the example that you mentioned on the air traffic control, so I imagine that this is a very, say, legacy heavy environment where you have a system that is working just fine and you shouldn't touch it because air traffic depends on it. So how is the integration of AI then managed? Is that run in parallel to the existing system for some time? Is it a top up? How can we picture that working efficiently?
So we didn't, as I mentioned, so these are very slow integration, very careful and slow integration. So they're expecting assistance to humans by 2035 and only full automation by 2050. So as you see, there's a lot of legacy that's already working. So if I understood correctly, this is going to be they mentioned it's quite a slow integration. And actually the problems are not really technical, but many times cultural. So what they have a project Bluebird that we represented, which is EPSRC and has 15 million pounds. So with this project, they are trying to improve this. And apparently it's a very unique project. There's only 2 other similar projects, maybe in China, if I understood correctly, but it's quite unique. So it's very new. So apparently the air traffic control industry is not really focused on this right now. So it's a bit early to start integrating that, but I think they're trying to do it with a lot of digital twins and they're working on simulation frameworks because first of all, they need to model accurately all of the traffic air control problems. So until we don't have that, they cannot even start thinking about doing it in
Right.
their systems.
I mean, if we take those 2 areas as a basis, Milan, in your session, what did you consider as the most transformative application of AI that came out of the discussion and the presentations? You're on mute.
Yeah, sorry. So if I have to narrow it down to the most important points, so one of the important point that was discussed by Dr. Boris was to use AI in more kind of doing a virtual experiments where you have a lot of input data and you kind of know you can build an environment around what are the tasks that you want to do using agentic modeling, and this will try to run an experiment for you and generate the data. Then it is up to you to decide what kind of whether this experiment is scientifically accurate or not. Now the control is more towards the user end. At the same time, it allows you to investigate multiple possibilities and kind of build upon that when you want to actually do some kind of experiments. Now there are also these models can particularly, because one of the questions asked by one of the uh, members was that can these model be used to write the paper from the data that is being generated by a human experimentalist. Okay, because the data reporting is really a tough task. So it was more of an interactive session where Dr. Boris actually demonstrated it, how the model was actually uh, generating a kind of sample papers which almost looks real. But there was also a questions asked about the ethics of how this data is being generated, because a lot of these kind of models can generate a lot of garbage which is not scientifically accurate, and that also needs to be a question which needs to be seriously considered before moving ahead on this one. So in that sense it was quite interesting.
Right, thanks. Joe, what about your session? What came out of as the most transformative application?
So this was it was AI for optimizing processes. We had Adam from KPMG and Maria from C.Dev. One is a large multinational, and the other is a startup. But there was a lot of commonality there on a few key things that came up. So the first one was stakeholder engagement. How AI can sometimes be viewed with a bit of skepticism, and there was some key themes there on how you engage with people, with customers, or whether internal users of the technology. And there's some key things that came out, things like making it easy to use, the easy integration, and also integration at a point when data exchange already takes place. So as far as users are concerned, there's no additional labor involved on their side. And then the other thing was integration into pipelines. So how you take something from proof of concept through to a production item. A lot of feedback is involved, monitoring how users are making use of the tools. Are they using them the way you expected them to? Are your new use cases coming up? And really tailoring the tools to the process and to the users. Similar to what someone just mentioned then, this idea of validation or evaluation, or a paper trail, as you would probably traditionally call it, the idea of what data has caused the model to produce this output, and making sure that there's traceability there. And then finally, that often people who are in a position to benefit most from AI don't know how it could be integrated into their pipelines. So a certain level of data exploration is required even at the offset, and then you go from quite an emotive response of being overworked or something like that to being able to put a metric on it and say, we've improved by this much in this area.
Right, thank you. I mean, a fantastic range of applications, and I guess that just illustrate what was said this morning in the presentation, that AI really enters into all sorts of different sectors and at a pace that we have not seen before. The one area that I would like to dig a little bit deeper into, and maybe starting with you, Andrea, because it came up already a little, are questions around integrating AI and managing the relationship between what I would call innovation on the one hand, where you can really go into a new paradigm, and the risk that you have to accept by the new technology. How was that evolving? How was that presented in your session?
So there were several things. One thing that I think is very important that was mentioned is metrics. So how do we measure safety? How do we measure how fast something needs to be solved? So those metrics are apparently very complex to capture. So there's an actual difficulty right now in defining those functions. So first of all, one needs proper metrics that work fine in all of these high risk situations. And another one was, for example, we had the LLMs. We talked about LLMs in the second talk, which is a stochastic model and cannot be evaluated as software. So you need like specific evaluation benchmarks for statistical models. And that also applies to the air traffic control, because they said they want a sequential decision making, but with probabilities. This is really important in safety. They would like to tell you, if you do this is going to be successful with this much of a probability. So with this stochasticity, they need also specific evaluations for that. So I think that was also very interesting.
I mean, that interesting interaction between risk and opportunity or innovation, Debdeep, how did that come across in your session where you were talking about those clinical applications?
Well, I mean, it came quite a bit also in both, to be honest, from the talk on Miriam and on PhysicsX. But while the PhysicsX talk from the PhysicsX really highlighted the area where it was mentioning the trust issue, for example, while adopting. The main barrier was whether engineer and operators trust the AI predictions. If misplaced trust or misunderstanding of the AI uncertainty can lead to a costly error, depending on how high-stake customers you have. And then, of course, the quantifying uncertainty and integrating physical constraints there as well. So we need to carefully opt for an approach which enables us an evidence-led process improvements and support the shift towards AI-augmented manufacturing. And on the spectroscopy side, the main issue was the data risk. So there's a data-starved nature mentioned in the talk. in this field. That means like models may be trained on an incomplete or simulated data, so which can be biased, or a little bit there's a gap between the real world and the Monte Carlo one. Then difficulty in embedding domain expertise into an AI models can lead to misinterpretation of the results as well. So something like that as well.
Right. In the little remaining time we have, I would like to take a look into the future and see where are we actually going with this. And I'd like to understand what were the most urgent questions or research directions that came up in your different sessions over the next maybe 3 to 5 years or so. Joel, would you like to give it a start?
Yeah, so we had this discussion around the balance between augmentation, or human in the loop is the technical term that was brought up, versus full automation. And at the moment, there's a real focus on low complexity, high volume tasks, which don't necessarily have the risk associated with them, but there is a lot of gains to be made. And then the side to that is that there is work going on in terms of automation in the more complex tasks, but they do require a lot more work, and that's probably the direction that things are going to go into longer term. So the example that Maria gave was the idea of someone underwriting a loan. That's a very human-driven task at the moment, but there's been a recent paper which is looking at how you could automate that. And obviously then different loans have different complexities. A small business looking for a startup loan versus someone getting a mortgage, it's very different. So yeah, that's probably the direction it's going in longer term.
Right. What about your session, Milaan?
Yeah, so one of the critical questions that was asked was about the ethical nature of the data generation and the authenticity of the data that model generates, because both talk essentially narrowed down to an AI model which basically does the experiments at the same time generates the paper, and the parameter it takes as an input for analyzing those experiments was based on another generative pre-trained models, which basically is trained based on this vast database, which the original user may not have fully control on. So AI models generating experiments, doing experiments, and generating the papers are then being transferred to another AI models, which are then using those data to do further analysis. Now, the real challenge is in the validating, or the role of human over here is to validating the authenticity of the data that is being generated, and the resources it collects from the already published literature and concerning all the plagiarism issues, and the most of the good quality of research which is being used as a input for those models are behind the paywalls, and how to essentially navigate through this scenario. That was one of the main challenges that was discussed in my session. Yeah.
Thanks. Well, thanks a lot, Milaan, and thanks a lot to all of you. We've already reached the end of our session. It's crazy how time flies when you're having fun. Really great to see just how much was covered in such a short period of time. And with that, a big thank you to all 4 of you, and of course also to everybody who contributed to the discussion in the different sessions. And over to you, Alex.